Yeah, hi everyone. So please join the session fast so that we can start the session. This is going to be counting lecture number 8, and this is going to be a final session. And after that, I will be starting probability and statistics, right? So I hope everybody is doing well in permutation and combination. And I have given you 7 lectures. So many concepts were new, and I think you might have understood, right? So there are few things that you have to learn. Okay, one is overcounting. You always be ready to overcount the thing, and you should also be ready to correct because correct the thing, right? So you can do many mistakes, but you should be also ready to make corrections as well, right? That is what the thing is. Okay, so let me inform everybody to join the session. Uh, yes. So in this session, what I'm going to talk about, I will be talking about distribution of alike objects, and I will talk about dearrangement concept, right? These are the two concepts which I will be discussing, and then I will conclude everything. Okay, so now you have to practice many problems, and if time will permit in future, I will conduct again one short session. Okay, so you can expect some problem solving session also on this. Okay, fine. So here, the very first concept is what I'm going to talk about here is the distribution of alike objects. Alike, you can say objects. Distribution of alike objects. Okay. And second concept I will talk about is today the dearrangement concept, right? Dearrangement. Dearrangement. Okay. In case of dearrangement, basically what we are going to talk about is suppose you have got three envelope and three letters, right? Okay. Suppose you want to send three letters to your different people. You can say you are sending one envelope to your father, one envelope to your uncle, and one envelope to your, you can say, to your brother, right? So in case of dearrangement, what we have to do here is we have to put the letter into wrong envelopes, right? Okay, suppose one envelope belongs to father, but I'm going to put the letter in place of father envelope. That letter can be put like uncle letter we can put, right? So we have to make the mistake here. Dearrangement is the same only, right? We are not going to arrange properly, we are going to do a dearrangement, right? So this concept is the last concept that I will talk about. So what is the meaning of distribution of alike objects? So I think many of you might have studied about, we have discussed about distinct objects. We have discussed about permutation for distinct object, permutation for, selection of distinct objects, right? Now I'm going to talk about distribution of alike objects. So here one important concept you have to use while solving the problem. That important concept is what? Important tool, you can say. The important concept is here, we are going to use one principle called beggar coin principle. Okay, beggar coin principle. So you will be able to solve the question very quickly if you are going to learn this principle. Beggar coin principle, or we say and ballistic method, even ballistic method. Okay, so this is, if you understand this concept clearly, you can solve any question, right? Whether it will be asked in your, you can say, in your any type of exam, right? So basically these type of concepts are used to solve any question very quickly for JEE mains and advanced, right? Okay, so I hope this makes sense. What you can do here is, suppose you have got uh, you can say here, suppose you have got six coins. So one coin, second, third, fourth, fifth, and sixth. These are the 6 coins. Okay, you have, right? Suppose you have got 6 coins, right? Now you have got three beggar, right? Suppose you have got three beggar, right? So you can say A beggar is there, B is there, and C. These are the beggars, right? So what you can do here is you can distribute these 6 coins to these three beggars, right? Okay. So you have to distribute. So how many ways are there you can distribute these 6 coins to these three beggars, right? This is a question. Okay, simple question. What you can do here is you might it might happen that you might give these all coins to this guy. Okay, and you I hope this makes sense, and you are not giving anything to these two, right? Or you can do, what you can do here, you can give 5 coins to this first beggar, and one coin to second beggar, and you're not giving any coin to third beggar, right? Okay, but in the question they might give you some condition also. Okay, at least one coin has to be given to the beggar, then you have to be little careful, right? Okay, so it depends upon the question. If any restriction is given in the question, then you have to take care of that restriction. Understand? If there are six beggar A, B, C, okay, six coins are there, and you have to distribute these six coins, okay, to these beggars, right? And these coins can be same, you can say, right? Same coins are there, 2 rupee coins, 3 rupee coins, whatever rupee coins, right? So then you can note down, like suppose you're giving zero coin to this guy, zero coin, and you can say six coin I'm giving, right? Or you can also distribute these all coins, like each beggar has got two coins, right? You can say. Okay, so I think this is clear. Okay, so what is the meaning of that? How many coins are there here? There are six coins, right? There are six coins. Okay, and you are distributing to three beggars. So what is the meaning of ball stick method? That is also you have to keep in mind. So suppose you have got six coin here. Okay, six coins, right? And you have to distribute these six coins among three beggars, right? So what you can do, you can draw here two sticks always, right? Suppose there are three beggars. Okay, so you have to draw two sticks. Okay, how many beggars are there? Three beggars are there, you can say. So how many sticks we have to draw here? We have to draw two sticks. Always keep this in mind. Okay, okay, so now we can find how many ways we can distribute these things. So there are six coins and there are two sticks, you can say, right? So you can find the total you can say total number of ways. That will be, total is 8 upon 6 coins are same, so you can say 6 factorial, and there are two sticks, so 2 factorial, right? This you have to keep in mind always, right? Understood? So this is very important to keep in mind. These sticks you can place anywhere, right? These sticks you can place like this also. Okay, suppose you are putting a stick here, and then there are three coins, again you are putting a stick here, right? So you can say that left to this stick, A has got one coin, and here B has got three coins, and C has got two coins, right? Like this you can say. Okay, understood? So you can replace these sticks here and there, and you can see number of coins which beggar is going to get, right? So instead of doing so, what you can do always is, you have got six coins. Okay, you have got six coins, keep in mind, if you have got six coins, okay, and then you have got three beggars, and you have to distribute six coins to three beggars. तो आपको क्या करना है यहाँ पर? You first take two sticks here, because there are three beggars, so you just take two sticks. Okay, and these two sticks are going to be play like a divider, you can say, right? Okay, yeah, they are going to divide, okay, number of coins. ठीक है, तो आपको हमेशा याद रखना है, दिस इज द प्रिंसिपल. ओके, दिस प्रिंसिपल वी कॉल इट बिगर कॉइन प्रिंसिपल और बॉल स्टिक मेथड, और यू कैन से बॉल स्टिक मेथड. Hopefully this makes sense to you, right? So let me take one question so that you can understand here and use this principle. Okay, we call it beggar coins principle. So question here is nothing but, find the number of ways, find the number of ways 30 mangoes in which, you can say, in which, find number of ways in which 30 mangoes can be distributed among 5 persons. Can be distributed among 5 persons, you can say 5 persons. Okay, 5 persons. I hope this makes sense, right? So what you have to do here is find the number of ways in which 30 mangoes can be distributed among 5 persons, right? Okay, so let me solve this question using the concept we have discussed, using the principle we have discussed. Okay, now you see this question can be done in a second, right? Okay, but as we are engineers and we are not from IITs and NITs, okay, we are studying in some normal college. Okay, so we never focus on mathematics properly, but now in India or across the world, mathematics is the demand. Okay, So everyone started putting their own effort, okay, to learn mathematics. That is how I also started learning mathematics in the middle of pandemic, you can say, right? Before the pandemic, my interest was also zero. See, so yes. So how we can solve this question? You see, what they are saying is find the number of ways in which 30 mangoes. Okay, these 30 mangoes are same, alike objects, right? And there are 5 persons. You can say there are 5 beggars, right? 5 persons you can say, or 5 beggars, and these 30 mangoes are, you can say, coins. There are 30 coins and 5 beggars are there, right? Okay, I hope this makes sense. 30 coins and 5 beggars are there. Okay, what you can do is, suppose there are 30 mangoes, you can say one mango, second mango, and there are 30 mangoes, right? Understood? 30 mangoes, these are 30, and there are 5 person, means there are 5 beggars, right? You can say A, B, C, D, E. There are 5 person or 5 beggars. So how many sticks you have to draw here? 1, 2, 3, 4, 4 sticks. Okay, understood. So we are using what? We are using the beggars coin principle and ball stick method. Okay, okay, that you have to keep in mind. So we have to draw 4 sticks. Don't draw 5 sticks. Okay, if there are 5 person or 5 beggars, so draw the 5. Okay, so these are 4 sticks. Now how many ways we can we can find number of ways here, right? So how many total? You can go for over counting, like 34 upon the, you can divide by 30 factorial and 4 factorial. Understood? 30 factorial and 4 factorial. So this is the answer for this question. You can solve it. 30 factorial, 34 factorial upon 30 factorial upon into 4 factorial. Okay, so I'm using over counting and correcting here as well. Okay, so find the number of ways in which 30 mangoes can be distributed among 5 persons. So this is the number of ways. Okay, you don't have to check each person how many mangoes each persons are getting, right? Otherwise, if you start finding the cases, then it will take a lot of time. Understood? So I think this is clear. So let me take one more question here. I hope this question is clear. So as we have to finish this topic today itself, right? So I'm just in hurry as well, and I hope you are getting now. You have understood the way I teach, and you have understood my momentum as well, right? So question number 2 is what? Find the total number of ways. Find the total number of ways. Find the total number of ways of distributing 7 identical computers. You can say 7 identical computers. 7 identical computers to R, S, and G, right? So there are R, S, and G. You have to distribute these 7 computers to R, S, and G, right? So that देखो यहाँ पर कंडीशन दिया है. अगर कंडीशन नहीं दिया होता, if there is no condition at all, what you can do? You can simply distribute 7, and there are 3 beggars, right? So 7 computer, you can take 7 computer as a 7 coins, or 7 coins. You can treat all computer as a coin, right? As you are dealing with permutation and combination, right? And then what you can do here is you can take 2 sticks and finalize everything, right? But here there is a condition, so that each receive at least one computer. Okay, one computer. Understood? So let me solve the question here. Again, this question will take only 10 seconds to answer this question, right? Okay, so as you know, whenever I solve question, you know, the way we can solve the question, more than speed of light as well, right? Understood? The speed. So find the total number of ways of distributing 7 identical computers. Here alike objects are there, and we have to distribute them to RSG, right? So there are 3 beggars, you can say, and there are 7 identical computers, or you can say 7 coins, right? So such that each receive at least one coin, that you have to remember. So there are 3 beggars, R, S, and G, and See, there are how many coins are there? 1, 2, 3, 4, 5, 6, 7, right? 7 coins are there, right? But they are saying that at least each receive at least 1 coin, means there are 3 beggars, okay? And you're going to give them like once they will return their home, you can say that they are not going to return their home with empty handed, right? They are going to receive at least 1. तो मान लो ऐसा करते हैं कि out of 7 you have given 3, like already you have given 3. 1 coin I have given to this guy, 1 coin I have given to this guy, 1 coin, 1 computer I have given to this guy. So how many? So you can say these 3 has already distributed, okay? Understood. Now there are 4. Now there are 4 computers left, okay? And you have to arrange them. You have to arrange them, okay? So you have got, now you are left with 4. Understood. So already 3 computer has been distributed to each one, right? At least 1 is there now. At least 1 means 3 computer already you have given 1 1 1, right? Now you have got 4 computers, right? You see there are 4 computers. By mistake I have cut this also, so just consider this, right? So now there are 4 computers, okay? So you can say that 1 2 3 4. And how many beggars are there? 3 beggars. So you take 2 sticks. Now you can arrange this: 4 computers, 4 coins, and 2. So this will come out to be what? 6 factorial by 4 factorial and 2 factorial. This is the answer for this question, right? I hope this makes sense. Okay. So what you have to make sure that here the condition is given. Since the condition is given, you have to consider, okay, you should now, you have to give at least 1 computer to each beggar, okay? You have to give, don't consider, don't take it negatively, guys. Persons, not all persons are beggar. I mean, I'm just talking about the principle, right? To solve any question quickly, right? So that each receive at least 1 computer, okay? RSG. RSG. Okay, this is very important concept that you have to remember. So this is the answer for this question. Okay, so I think you guys can solve it. Okay, मान लो ऐसा क्वेश्चन आता है इसी में, सेम क्वेश्चन नंबर 3, right? Suppose there are 7 computers, 1 2 3 4 5 6 7, right? And you have to at least 2 computer आपको देना है. At least 2 computer you have to give to 3 persons, A, B, C. And at least 2 computer, मतलब आप इसको 2 coin दे दिया, 2 coin दे दिया. So how many coins you have given here, right? How many coins you have given? That is very important to understand. So 1 2 3 4 5 6. 6 coin already you have given, right? So how many coins are there? 1 coin is there, right? And how many beggars are there? 3 beggars. So 3 beggars means 2 stick, right? So you can arrange 3 factorial by 2 factorial, right? So this is the answer for this question. Okay, so at least, if at least is there, right? If there is a condition, so you have to accept that condition. You have to think logically, right?
Study material leaving you stuck in.
Okay, so that is very important to keep in mind. Understood? Yes. So let me go ahead and take more problems. I think this concept is clear. Okay, if you have any sort of doubt, you guys can reach me out anytime. Okay, so this is very important concept. So beggar coins principle. Okay. Now let me take one very good problem, okay, from the number system. What is this question is? The question is find the number of natural solution. Find the number of natural solution. I'm very sure that many of you might not be able to solve this kind of question. It takes a lot of time for you to solve. Find the number of natural solutions of equation, right? Of equations x plus y plus z equal to 102, right? Where they have said that x, y, and z belongs to the natural number, right? These x, y, z should be natural number. Okay, find the number of solutions. You have to find number of natural solutions of the equation where x, y, z are what? X, y, z are. This is very important question, okay? And many of us are not able to solve this kind of question, right? Okay, it takes a lot of time for everyone. How many combination you will check, how many cases you will check, right? So if you're going to use this method, what I call it, you know, uh, a beggar's method, okay, or ballistic method, okay, so you can solve this question very quickly, right? What you can do here is, see, now you can say that there are how many coins? There are 102 coins. This you can say there are 102 coins and there are three beggars, right? But there is a condition here they have mentioned. What they have mentioned here is x, y, z should be natural number. Okay, so you have to at least give what? You have to at least give one coin to each beggar, right? One coin. You can't give zero coin to each one beggar. I mean, no beggar should be no beggar should go back to their home with no coins, right? Remember, okay, so here zero cannot be given, okay, because one of the combination can be 0 plus 102, right? It can be 0 plus 102, right? But here they have said already xyz should be natural number and 0 is not the natural number, that we know, right? 0 plus natural number is going to be the whole number, but 0 is not the natural number. So at least one, this condition is what? At least one of the coin has to be given. That is very important, right? So how many coins you have to give then? That is very important. At least one, right? So this is very important to keep in mind. So what you can do here is you just take x plus y plus z equal to 102 and now you start distributing here, right? So you can say that if you're giving 100 plus 1, right? So this is one way, and next way you can consider any, right? You can say 99 plus 1 plus 2, right? So this is possibility, right? But don't take 102 plus 0, right? That is wrong because x y z should be natural number, right? I hope this makes sense to everyone. So at least one coin has to be given, right? At least one coin. You can say that there are total how many coins are there? 102 coins, and there are three beggars x y g, right? And one coin you have given, one coin you have given already to them. So remaining how many coins are there? There are 99 coins now. And how many beggars are there? There are two beggars. There are two beggars, okay? Understood? So how many ways you can, so there are 99 coins and there are two beggars, like three beggars, but two sticks are there, right? Two sticks, okay? So how a number of ways if you want to find, so total how many are there? You can count here, right? So 99 plus 2, what? 99 plus 2 will be 101 factorial upon 99 factorial and 2 factorial. This is the answer for this question. Okay, I hope this makes sense to all. So you guys can solve it. Huh? See how fast we can solve this question. Otherwise, if you try to find the cases, in fact, you know, one of the interview I was giving and one guy asked to me, can you tell me the highest prime number? Okay, so I was stuck, you know, I was stuck. That too, you should always think, there can be, you know, highest prime number is what? There are infinite prime numbers, okay? So highest you can't decide, okay? The smallest you can talk about. So thinking is very important. So sometimes in the interview they ask very basic question, right? Okay, suppose you're going for mathematics, right? So to eliminate you, right? So find the number of natural solution of the equation x plus y plus z equal to 102, where x, y, z belongs to n. Okay. So I think this is clear. So this will be the answer for this question. And next we take here next question. So next question is here. Suppose you know you have been given number of. You have to find number of non-negative integrals. Non-negative integral non-negative integral solution of the inequality okay, you can say x plus y plus g should be less than or equal to 30, right? So number of non-negative integral solution of the inequality, you have been given this now. So there is an inequality that you have to always keep in mind whenever there is an inequality like this. Okay, so how do we apply that principle, right? That is very important to understand. So in this case there is an inequality, x plus y. There are 3, you can say, beggars, and there are 30 coins, right? Okay, there are 3 beggars and 30 coins. So number of non-negative integral solution of this inequality you have to find. So it takes a lot of time for many of us to solve this question, right? Then how can we solve? How can we solve? I think there is one more coin is there. Let me write correctly. So 1 minute. This is x plus y plus z plus t. Okay. There are 4 points, you can say. This is less than or equal to 30, right? So whenever there is an inequality kind of thing, you have to remember always, then you have to choose one false beggar, right? False beggar. Why you are choosing false beggar? You can keep yourself, you can make yourself as a beggar, because you're not a beggar basically, but you can say that, yeah, I'm also a beggar. So you are a false beggar, right? Why I want to do so? So that this inequality can become equality also, right? This equality can become equality, right? So you can say that x plus y plus z plus t plus one false beggar is there. You can say fv, false beggar. Now it will become 30. Right? Now it will become 30, right? Okay. So whenever there is an inequality, keep in mind, so you have to bring the concept of false beggar. You have to become a beggar, then you can say, and then put false beggar over there. So this inequality will be disappeared, then it will be same, right? Okay. So what we can do here is now there, how many beggars are there, you see? Okay, so how many beggars are there, that you have to keep in mind. So there are 5 beggars. So you have to take 4 sticks, and how many coins are there? 30 coins. You can say that 30 coins are there and 4 sticks. 30 coins, 4 sticks. So how many ways are there? 34 upon 30 factorial and 4 factorial. Okay, 30 factorial and 4 factorial. So I think this is clear for all, right? Okay. So what is this? You can say this is nothing but 34C4. 34C4. Sometimes you can also write like this, 34C4, right? So it's a very good concept, right? It's a very good concept that you can use to solve this kind of a problem. Now let me take one more problem here so that you can understand all the concepts. So question number next is, you can say that the total number of 3-digit number, the total number of 3-digit number, okay, numbers whose sum of digits is 10. Okay, you have to find total number of 3-digit number whose sum of digits is 10. So there are digits, okay, you have to add all the digits, so you should get the sum as 10. So again, this is a problem of, okay, this kind of problem was asked in M20, right, in mains 20, right, that you have to remember. Okay, so here you can use the same concept. So what is the important condition here? The total number of 3-digit number whose sum of digit is 10, right? So whose sum of digits should be 10, right? So you have to make 3-digit number, right? 3-digit number means what? The digit you have to choose, this should not be 0. Okay, like if you are going to put 0 here, so that will be a what? That will be what? Can somebody tell me what will be that? So you can say that there are x, y, z, these are 3 digits, and sum of them x plus y equal to 10, right? Okay, so your x should lie between 1 to 9, right? Your y should lie between what? It can lie between 0 to 9, and your z should lie between 0 to 9. But x should not lie between 0 to 9. That is very important to keep in mind. Why? Because if you are going to take 0, so that will become only 2-digit number, right? But you have to get 3 digits. So this is the condition that you have to always keep in mind, right? This is a condition that you have to always keep in mind. So if you have given 1 coin to x, right? If you have given 1 coin, there are how many coins? There are 10 coins. At least 1 coin should be given to x, right? At least 1, right? At least 1 coin has to be given to x. This is certain. 100% you have to give 1 coin to x. if you're not going to give one coin to x, then that is wrong. Okay, क्योंकि x cannot be 0 here. Understood? तो अगर एक कॉइन आप x को दे देते हो तो कितने कॉइन बचते हैं बताओ? 9 coins. So you can say that there are 9 coins. And how many beggars are there? There are 3 beggars. You just put two sticks. So you can say that this is 9 to 11 factorial by 9 factorial and 2 factorial. Okay, understood? This is very important to keep in mind. But what we have done here is one very important point you have to keep in mind here is, see, once you have given one coin to x, right? One coin to x you have given, right? So how many coins are there? 9 coins. But while giving to y and z, okay, while see y can take 0 to 9, z can take 0 to 9, right? Okay, so you have counted extra also, right? You have counted one case extra that you have to always keep in mind. This is very important too. Okay, so you can say that suppose you have given 9 coins to this guy, okay, and इनको कुछ नहीं दिया, ठीक है? So this is very important, this case, and this case has already been counted also, right? 9 coin you have given to x, and then 0 coin to y, and this. Okay, so already you have given one coin here, but this case will be extra here, so you can say 1 minus you have to do here in this case, right? 1 minus. Okay, 1 minus is very important, right? So if you are doing something extra, so you have to subtract it. You have to subtract. So if you compute this, you will get 54 as the answer. Okay, 54. Understood? So this is here you have to take care of. That's it. Now let us take one problem. I think these problems are always ignored everywhere. So the total number of positive integrals, the total number of positive integrals, the total number of positive integral solutions x comma y comma z, right? Okay, such that x y g go to 24, right? So you have to find total number of positive integral solutions, right? So if you take x y g, so the product should be 24. Product should be 24. Okay, so what are the answer here? A, B, C, D. So options are given like 36, 45, 24, 30. Okay, so it was asked in mains 2021, right? You can say. Yeah. So the total number of positive integral solution x y g such that x y g is equal to 24, right? So 36, 45, 24, 30. 36, what you can say, 36, 45, 24, 30, right? So what is the answer here? Can somebody tell me? So if you start making the cases, it will take 2-3 days, but you have only 3 hours, right? And that too in 3 hours you have to solve 65 questions. Okay. तो अगर आप कॉम्बिनेशन बनाना चालू कर दो तो क्या हो जाएगा? There are 3 beggars x y g, right? And you have got 24 coins, you can say, right? तो एक बेगर को आपने 1 coin दिया, इसको 1 coin दिया, इसको कितना दे दिया? 12 coins, sorry, 24 coins, you can say. You can give 24 coins, right? Okay, I hope this makes sense. Then you just keep making, right? Okay, but here the product is there, right? That you have to keep in mind. So 1 into 2 into 12, right? You can take like this, then 1 into 3 into 8, and so on. So many cases you will get. Okay, but the answer should be given on time. Okay, you should not take much time to answer the question. Okay, so आज का session is very important session for everyone. You don't have to miss this session. Okay, fine. So let me give you the shortcut here, like how can you make it, right? Okay, so suppose you have got x y g, it is a product, right? And there are 24 coins. Okay, so try to, what is the prime factorization of this? Prime factorization, इसका prime factorization क्या हो जाएगा? You can say 2 to the power 3 and 3 to the power 1, right? You can make what? Prime factorization of this. Okay, so you can say that there are 2 rupee coins. Okay, there are three coins are there. 1 coin, 2 coins. Okay, so these coins are same. 2 rupee coins are there, right? And there is 1 coin that is 3 rupee coin. Okay, understood? So you have to distribute X, Y, Z. There are 3 beggars. You have to distribute 2 coins to these 3 beggars, 2 rupee coins, and there are 3 coins, and you have to distribute these 1 coin to 3 beggars, right? This is the question here, right? So this shortcut you can use when there is a product of X by G, right? So how many ways are there, guys? You can write here. So you can say that there are 3 coins, 1, 2, 3, and there are 2 sticks. Why 2 sticks? Because there is 3 beggars. You can say that 5 factorial by 3 factorial and 2 factorial into. Now there is one guy, I mean, there is only 1 coin, you can say, and there are 3 beggars, right? So you can say that 3 factorial by 2 factorial. Okay. So here 1 factorial also you can write, right? So one condition will be here, 1 coin and 2 fact. Okay. So this is the case that you have to remember. These are the sticks, guys. Don't take 1. Number of sticks. Depending upon number of 1, always you have to take 1 less than the number of beggars. ठीक है, ये clear हो जाता है concept यहाँ से. You guys can solve any question, right? So how many ways will be there? Total answer will be 30 in this question, right? अगर आप solve करते हो तो 30 your answer will be. Now the last topic of permutation and combination is what? Dearrangement, right? Dearrangement. Dearrangement you have to say. Derangement you can say. Derangement. Okay, so this is very important topic. So I'm just going to give you one statement here that, and one formula you have to remember, okay, for solving this kind of question. Derangement. Derangement. Understand? So this is the last topic of PNC, and now you have to practice a lot, right? There are questions which you have to take and you have to practice. So what is the statement here? Suppose you have got n things are arranged in a row. If, let me choose a thick pen here, right? If n things, okay, you can say n things are arranged in a row, right? In a row, the number of ways they can be dearranged, number of ways they can be deranged, okay, deranged, so that R things occupy wrong places. R things occupies wrong places. ठीक है, आप ऐसा सोच सकते हो, ये बहुत अच्छा है. मान लो तुम्हारे पास 5 लेटर्स हैं, 3 लेटर्स ऐसे हैं जो रॉन्ग प्लेस को ऑक्युपाई करते हैं, 2 लेटर्स ऐसे हैं जो कि राइट प्लेस को ऑक्युपाई करते हैं, राइट? मतलब आपके पास 5 letters are there, right? 5 letters are there and 5 envelopes are there. So you can say that 3 letters will go to right envelope, sorry, wrong envelope you can say, and 2 letters will go to right envelope, right? ऐसा सोचो. So if there are n things are arranged in a row, right? The number of ways they can be deranged so that R things occupy wrong places, while n minus R things occupy their original places. Occupy their original places. Right. So इसका फॉर्मूला क्या हो जाएगा? NCR dr. That you have to remember always. NCR dr. Right. So you have to find the combination. What? the you can say the latter which are going wrong, they are occupying wrong places. So NCR and DR, right? Don't think about right. Okay, don't talk about right. What is this DR that you have to remember? So this DR is nothing but, where DR is going to be what? R factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. देखो, 1 alternate sign, 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus and so on, plus you have to keep in mind minus 1 to the power R 1 by R factorial. This is a formula that you have to remember. Okay, in fact most of the students, not only students, in fact mentors, faculty, teachers, everybody has a doubt on this topic, but you will not be having if you follow this technique. Okay, understood. So you have to remember some values also. The values are like, suppose you can say that, suppose you have got 3 letters, one letter is this, second letter is this, third letter is this. This letter can be, you can say, your father letter, you're sending to your father, you can say sister, and this is brother. And there are envelopes, you can say, these are the envelopes, you can say, 1 envelope, 3 envelope, right, and 4th envelope. Okay, so you can say this is sister envelope, this is father envelope, and this is brother envelope, right? So what you can do here is you have to dearranged. Okay, you have to keep these letters in wrong envelope, right? So you can say father letter has been kept here, sister letter has been kept here, and brother letter has been kept here. So there are 3 wrong letters, 3 wrong, you can say wrong places are 3 wrong places, right? So what will be the answer here? D3. It will be D3, right? D3 will be, okay, D3, understood? 3C3 D3, understood? This is very important to keep in mind. So D3 will be the right answer, right, in this case. So D3 you can compute. Okay, so there are some values that you have to remember for your exam to solve this kind of a question. So suppose you have got dr, again let me write r factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus minus 1 to the power r 1 by r factorial, right? So what is the value of d0? D0 is 1, d1 is nothing but, you can say, 0, right? D2 you can find these value and you just remember it. Okay, just I'm giving you these values, right? So d1 is nothing but 1, d3 is 2, d4 is 9, and d5 is going to be 44, right? So ये आपको याद रखना है, और simply remember this formula. As we are engineers, so we should not become afraid from these formulas, right? I think this is clear for all, right? Yes. So let me move ahead, and so let me take one problem here. So you can say that suppose you have got 5 letters, right? 5 letters, and you can say that 3 letters occupies the wrong place, and 2 letters occupies, you know, the right. Okay, so how many ways are there? How can you dearrange, right? So answer क्या हो जाएगा इसका? 5C3 and D3. ठीक, 5C3 D3. This is the answer. Okay, so you can generalize here. Suppose there are n letters. Out of n letters, R occupies you can say wrong envelope, and n minus R occupies right. Okay, तो आंसर क्या हो जाएगा इसका बताओ? NCR DR. I hope this makes sense. So this is how we do dearrangement, right? एक question solve करते हैं. That question will wind up the session here, right? So I will wind up the session with that question, and then later we will talk in future if anything comes out to be right. So okay, so in fact I will record one session, you know, you can say recording, I will do one recording here, right? The overview of summary of everything, and then I will upload on the YT so you guys can check out later, right? बट अब याद रखना काउंटिंग से डर हट जाना चाहिए, ठीक है? काउंटिंग से डर हट जाना चाहिए, ठीक है? तो मान लो ऐसा क्वेश्चन आता है कि a person writes a letter to 5 friends. A person writes a letters to 5 friends, okay, and addresses the corresponding envelope, and addresses the corresponding envelope, okay, corresponding envelope, okay. In how many ways can the letter be placed in envelope? In how many ways can the letter be placed in the envelope? So that okay, first is all the letters are in wrong places. All the letters are in wrong places. ये तो डायरेक्ट आंसर है, राइट? डायरेक्टली यू कैन आंसर द क्वेश्चन. ऑल द लेटर्स, तो अगर 5 लेटर्स है, ठीक है, 5 फ्रेंड्स 5 लेटर्स, तो D5 आंसर आ जाएगा, ठीक है? अब मान लो ऐसा देता है कि एटलीस्ट 3 ऑफ देम आर इन अ रॉन्ग एनवेलप. एटलीस्ट 3 ऑफ देम are in wrong envelope. Okay, so what is the solution for this? Yes, तो पहले का आंसर क्या हो जाएगा? फर्स्ट तो डायरेक्ट है, D5 आंसर है. आई थिंक मेरा क्लास लेने के बाद तो आपको टाइम नहीं लगना चाहिए ये सब आंसर करने का, सोचना भी नहीं है. D5 का आंसर 44 आता है डायरेक्ट, ठीक है? अब एटलीस्ट बोल रहा है, एटलीस्ट का मतलब क्या होता है? एटलीस्ट 5 लेटर्स आते हैं, एटलीस्ट कितने होने चाहिए? 3. तो मान लो 3 रॉन्ग हो गए, 3 रॉन्ग, ओके. तो आप क्या बोलोगे? 3 रॉन्ग हो सकते हैं, और क्या हो सकता है? 4 लेटर रॉन्ग, ठीक है, और क्या हो सकता है बताओ? 5 लेटर रॉन्ग. तो इतने कॉम्बिनेशन आ सकते हैं, मतलब, ठीक है? तो 3 लेटर रॉन्ग, ओके. सो आपको यहाँ से करना है बढ़िया, 5C3 D3 प्लस 5C4 D4 प्लस 5C5 D5. आंसर आ गया, ठीक है? तो जब आप इसको सॉल्व करोगे तो यहाँ से आ जाएगा 10 इंटू 2 प्लस 5 इंटू 9 प्लस 1 इंटू 44. तो टोटल आंसर कितना आ रहा? 109. एटलीस्ट 3 बोला है ना, तो 3 कैन बी रॉन्ग, 4 कैन बी रॉन्ग एंड 5 कैन बी रॉन्ग, राइट? करेक्ट का चेक ही नहीं करना है, रीअरेंजमेंट का मतलब करेक्ट का चेक नहीं करना है, राइट? ठीक है, अब आप लोग क्वेश्चन सॉल्व कर सकते हो. माय फाइनल रिमार्क is what? if you want to really good at you want to be good at PNC, तो आप लोग JEE मेंस एंड एडवांस के क्वेश्चन सॉल्व कर लो, ठीक है? तो आपको ये कैट के भी प्रॉब्लम्स जो आते हैं उसको भी सॉल्व कर सकते हो बस. और जो गेट में तो बहुत ही सिंपल क्वेश्चंस आते हैं, तो आप PYQ सॉल्व करो बस, दैट इज important, right? So for the practice this is important, right? For practice is, ठीक है? I think this is clear for all. So anybody, any type of doubt if you have, you can let me know. Yes guys, any doubt? I hope you guys might have enjoyed the session for today. This is very important session that I have talked about today, and this was like, this topic is very interesting. In fact I have covered all the topics. तो आप लोग अब प्रैक्टिस करना चालू कर दो, राइट? ठीक है, so that will be the better for you all, right? So before I conclude everything, right? Concluding, if I like to conclude everything, right? So the conclusion will be what? What is going to be the conclusion here? In fact, I have talked about so many things, right? In next 5, 7 to 8 classes, I have talked about everything, right? So now you have to just revise it. That's it, okay? Fine. So let me give you a overview here, okay? Kind of conclusion, you can say. So just I'm looking at the slide here a bit. Suppose you have got what are the counting, basically we have performed the counting operations on n objects, right? So there are n objects can be distinct, objects can be indistinct, right? So what we have done exactly in entire course, right, of you can say PNC here, you can say that counting operations on n objects, ये summary है, summary, ठीक है? So this summary is very very important, right? So you can say here counting operations we have performed always, right? Because we are performing what? We are performing counting operations on the object, right? So yes, counting operations on n objects, okay? So there can be many situations, right? Let me take situations here. The first situation can be, suppose what are the operations that you can perform on an object, right? तो पहला ऑपरेशन आप क्या कर सकते हो? Sorting. You can sort it, right? I think people who are computer science like computer science background, so they always sort everything. Like आपके पास, suppose you have got observations, you will always sort it before you decide the median and all, right? So sorting is one of the thing. So if there are n objects, you always do sorting. This is counting only, guys, right? ये काउंटिंग है, राइट? सो काउंटिंग ऑपरेशंस ऑन एन ऑब्जेक्ट्स में पहला क्या है? सॉर्टिंग, राइट? सॉर्टिंग में क्या रहता है? बेसिकली ऑर्डर मैटर करता है, ऑर्डर मैटर्स, राइट? ऑर्डर मैटर्स. तो दिस इज कॉल्ड बेसिकली परम्यूटेशन. तो क्या बोलते हैं? परम्यूटेशन, यू कैन से in the language of PNC. Sorting is nothing but permutation where order matters, right? So what you can do here is you will find two kind of objects here, right? So if suppose n objects are there, all guys are distinct objects, right? Okay, you are going to perform operations on an object, right? And what you can do here is you're going to sort it, right? Sorting the objects where order matters, okay? So we call it permutation. I think you guys can recall one of the example I have given in the beginning only, that was, if you want to capture the picture, right? So you have to arrange people, right? Okay, so there can be distinct and distinct objects. There can be some which are not distinct, or you can say alike objects or indistinct objects. तो permutation आप दो में perform करते हो. One is distinct, right? And you can say some distinct, right? Or some indistinct, right? So what you can do here is, suppose, so here permutation will be n factorial. In this case, permutation will be n factorial upon n1 factorial, n2 factorial, and so on, right? I mean, you have to divide, you have to overcount, and then you have to divide by alike objects. Suppose n1, n2, n3, they are alike objects or same objects, right? Understood? So this is the permutation, and this is the overall view. I'm not showing you NPR formula, guys. NPR formula is like, kind of confusing one, right? So आप याद रखना है. अब बात क्या करेंगे? What other counting operation that we can perform on n objects? We can choose, right? Choose k, right? Out of n objects, we can choose or we can select. जैसे World Cup is going on, so if we have to form a team, so we have to choose it, right? We have to make selection, right? So second operation that you do is choose k, right? What is the meaning of this? this is basically a combination, we call it combinations in PNC, PNC paradigm. Okay, I hope this makes sense. तो यहाँ पर भी situations क्या हो सकता है, suppose there are n objects which are distinct objects, you can say distinct. अगर distinct हैं तो क्या करोगे, it will be like n choose k, you can say, right? So it is nothing but n factorial upon k factorial upon n minus k factorial. ये combination का formula है. Here also you are doing what? Here also you are doing kind of over counting, then you are correcting, right? That you have to remember always. Now suppose you have to put r objects in the bucket. You have got n objects, okay, and you have to put r objects in the bucket. Put in r objects, right? Suppose there are r buckets, you can suppose r buckets are there. Okay, if there are r buckets and there are n objects, okay, sorry, if there are r buckets, okay, so n objects are there and you have to put n objects into r buckets. Buckets means you can say r places are there, right? Okay, so if all the objects are, you can say if all the objects are distinct, right? If all guys are distinct, right? So what you can say, there will be two situations always, distinct. ठीक है. Okay, and here it can be non-distinct, you can say non-distinct. Okay, nothing is going to distinct. Okay, I think this is clear. So what you can do here is, this will be r to the power n, okay, put in r buckets, understand? And non-distinct means what will be there, you can say n plus r minus 1 factorial upon n factorial and then r minus 1 factorial. Okay, if nothing is going to be distinct, right? So I think this is clear. This is the summary, right? This is going to be a summary. Okay. And here you have to always remember one more concept, that is called over counting and correcting, right? This is one rule. Second rule you can remember is sometimes divide and conquer rule, right? Because that concept we are going to use in probability. So divide into stages and conquer, right? Conquer rule. And third one, what you have to keep in mind is these are very important thing that you have to remember. जैसे मान लो आपके पास दिया हुआ है, suppose one set is there and second set is there, right? This is one set, this is second set, you can say, right? Let me don't put here A and B. I can say this is A set, this is B set, you can say, right? So suppose you have to find number of objects in A union B, right? A union B. So what you will do, you have to find number of objects in A union B, right? So you're going to count first, right? So you can take, you can do over counting here, right? So you can say number of objects in A plus number of objects in B. So you have done over counting here, right? Over counting. Why over counting? Because you have counted this guy twice. तो आप क्या करोगे, यहाँ से subtract करना पड़ेगा, ठीक है? I think this is clear. Suppose you have got 3 sets. Okay. Suppose you have got 3 sets, right? Yeah. You have got 3 sets and you want to find number of objects, right? Like this. Total. So सबसे पहले क्या करना पड़ेगा? Number of A, number of B, number of C, right? Then what you have to do? See, you have over counted this one time. Again, you have over counted. So subtract. Okay, A, you can say this is A, B, C. A intersection B, A intersection C, right? Or A intersection, B intersection C, right? So many people think that why we are subtracting these things, because you have done over counting and you are just correcting it. Okay, these are the corrections you have to do, right? These are the corrections. This is the correction, basically. Correction. Over counting and correcting, right? Over counting and correcting is the rule that we are performing. ये सेम कॉन्सेप्ट प्रोबेबिलिटी में भी यूज होने वाला है, प्रोबेबिलिटी में, राइट, प्रोबेबिलिटी. सो व्हाट एवर वी हैव लर्नड इज द बेसिस फॉर प्रोबेबिलिटी, राइट. नेक्स्ट, so here you have counted couple of times, right? Now one condition will be there. Suppose there is one element, right, which is common to all, right, which is common to all. So it has been counted how many times, right? It has been counted, you can say 3 times, right? Okay, so here if you're find number of a, if you're finding, so 1 time, 2 times, 3 times, already it has been corrected here, right? It has been corrected by, okay, that common element is corrected already, right? So, but you have to choose that also. This guy has to be choose, you have to take it here. Okay, so this is not the correction, right? Okay, see, already you have done over counting, then you have corrected everything. Okay, but one of the elements, suppose it is present here, common to all, so that element you have, so you can say, so ये बहुत important concept है, right? And we'll meet in the next session, guys. Thank you, and let me know how was this session, and depending upon your feedbacks and responses, I'm gonna conduct future session. Thank you, take care.